You can go look up on Rode's website, their latest NT1 5th generation microphone. They call it the unclippable microphone. They say you can record the softest guitar to the loudest drummer without having to worry about setting your gain. Simply adjust your audio after recording. Now, I hate to call anybody a liar, but they are liars. Liars to sell you this microphone. They want you to sell the microphone by telling you a lie, and I'll explain why. If you think the gain knob is ever going to be obsolete, this video is for you. I'm going to explain why the gain knob will never, ever be obsolete. But I will make it, there is an exception where, yes, the gain knob can be obsolete. So here's a Rode NT1 from the company that says that the gain knob is obsolete with 32-bit float, which is a lie of unbelievable proportions. But anyway, it's just a condenser microphone. So let's just say that somebody built this at Rode. They built the condenser microphone, and they said, okay, how are you going to use it, Max? And I said, well, I'm going to use it like this. I'm going to talk into it, and this is, where I'm going to talk. I'm going to talk about 1 foot away from it. I'm going to talk at this level of voice, and this is how I'm going to use it. Well, the engineers would say, fine, we're going to build a preamp that's going to maximize the fidelity of your voice at the volume, at the amplitude you're speaking, and send it on its way, record it digitally or whatever. And then, yes, you don't need a gain knob. All a gain knob does is changes the resistance in the transistors for how the microphone works. But I just want to say, yes, you don't need a gain knob if you calibrate the preamp to the microphone for a given level of amplitudes of basically sound pressure changes, okay? So you need the gain knob, right? Because you don't know how loud the sound is it's going to reach the mic. It may be like I'm going to hold the mic 2 inches away, or maybe I'm going to hold it like 2 feet away. Maybe I'll have a really loud voice, or maybe I'll have a really soft voice. You don't know. That's the real world. The real world in using a microphone is you don't know the sound pressures that are going to transduce into an electrical current that's going to go to the preamp. And because you don't know it, you could have a very, very small current if I'm speaking loudly, or a very large current if I'm speaking, loudly. Then, you need to actually have the preamp adjust to that level. But I need to go very far back for you to understand why this is the case. And I'm sorry I've lost my voice. And I'm going to start with silver. Why not? I wish I had a copper bar, but I don't. But this is a silver bar. Okay. Now, let's just say that I see. Oh yeah, it's just silver. I'm going to actually. I see that tin or some other metal, aluminum, whatever, looks like this, and I'm going to make a bunch of these bars. Can get aluminum for like a cent for this charge. I'm going to take a bunch of these bars. I'm going to go sell it as silver to somebody. So I mint a bunch of bars in aluminum. It looks exactly like this. I bring it to the pawn shop, the silver dealer. I say, here's my 10 bars. I want $3,000 or whatever. And, what are they going to do? Well, there are a couple things that they can do, but the main thing they'll probably use, they use X-ray, I forget, anyway, they use X-rays, a little machine that will beam a bunch of, X-rays into the metal. They will hit the electrons. As the electrons come back, they'll make photons, X-ray photons, that will come out, and the other end of the machine will be like a silicon, like a material that will read the strength of those photons, convert them into electrons again, and from that property, they will know what metal it passed through, right? And I want you to keep that in mind. All metals, all materials have properties, very specific properties. You cannot make them up. You cannot make up a material and say, okay, in my microphone, I want to get, I want to amplify it to this level, and I'm going to make up a material that will get me perfect amplification, make the gain knob obsolete. Like to say the 32-bit float, again, that's so wrong. The only way the gain knob could be obsolete is if you had a perfect material in your transistors to amplify the signal with no loss of fidelity, whether the voltage was very small or very large. That's the only way you can make the gain knob obsolete. You'd have to have a material, an unobtainium material, to do it. So the way microphones are built, everything is built, is based on what these materials can do. You have to work with what the materials can do, what copper can do, what silver, nickel, whatever. All these materials, everything in your devices dictate exactly what you're going to get in your electrical currents. So this voltmeter, how does a voltmeter work? Well, when you put an electrical current through it, the people who designed this voltmeter have materials in it that they say, okay, well, if we get this amount of if this happens through this material, then we'll show you this number. And we just calibrate it to that. Why it works that way, we don't know. I mean, it's not, that's the other thing. I mean, just electrons. I mean, we have an idea of atomics, but they're still finding new particles that are part of electrons. Everything isn't known. We know how it works. We know that it does work. We don't know exactly why everything works. So again, in a microphone, you want to get the materials and manufacture them in a way, put them in a way that will get they'll get the quality you want. It's just trial and error experimentation. Every mic is trial and error built. So my favorite mic, the Electro Voice RE20, I think the latest design was like in the 80s. It's a 40-year-old mic, way before digital. Since digital came on the scene, mics haven't improved. FYI, go look. SM7, go look. An old design. Why? Because the equipment back then, even pre-digital, again, they optimized with that equipment to get the microphone to work as well as possible. What do you need a digital analyzer to know whether it sounds good or not, right? I mean, if you're working in an analog system, you don't need that, right? I mean, so all it's doing is storing the stuff, through a digital means. But ultimately, at the end of the day, everything recorded on mic just essentially goes straight to an amplifier. So yes, now we can digitize it, we can manipulate it, we can store it, but at the end of the day, it doesn't add anything to this. What goes to this goes to a speaker. So when they designed the SM7B, the SM58, the 57, the RE20, when they designed these mics, they set it up in a lab, somebody speaking, or they play known signals or whatever, and the speaker, they listen to the speaker, or they set up their analog apparatus to figure how they could get the best fidelity, the best sound from the materials at hand. Silver, copper, whatever. How many winds of the copper? How big of the magnet? What kind of magnet? All these things. The diaphragm. What kind of material for the diaphragm? And they tried, and they, through trial and error, they got the best thing. God does not come down and say, this is a perfect mic, use these materials in this way. Humans have to figure it out. And you can't read in a textbook all these theories, and the theories can say, oh, do this. A theory doesn't tell you what to do. A theory can tell you how things work, but it's still up to you to find out if it does work in real life when you assemble all these components together. But the main thing I want to get across to you is that the way a microphone works is there is a sound into the, let me take this thing. So I hope to take this apart so you can see the inside, but sound pressure goes into this. It's a little diaphragm connected to a magnet. The magnet goes back and forth, and it's surrounded by a copper wire. It induces an electrical field that creates a magnetic field that creates a electrical current that goes through these wires into a preamp, where it has to be amplified by at least like 6 transistors. So, or 20 more transistors, and we'll get to transistors in a second. Goes through all those transistors, amplified to line level, where now when you start copying that current, it doesn't degrade. The signal is there, it doesn't degrade, and it can be used in electronics to write memory, to whatever, to record onto a tape, stuff like that. keep in mind the currents coming out of this are tremendously small. Now, in a condenser microphone, it almost is like sort of like preamplified in that a voltage is already sent to the diaphragm in here, and it's already pre-charged. It's already like just on the point of shaking. So when your voice hits it, it shakes and it takes that current, the capacitance of that current, and it sends it through the wire. So this has a higher current voltage than this does because it's already pre-biased, and it already has a current built into it. Whereas this, all the current is created with your voice. If there's no voice pressure here, there's no current flowing whatsoever. No electron vibrates. In this, electrons are vibrating already because you're sending a current through it. Which is why these are very sensitive, but then also not as good at being low noise, because these, again, if it doesn't hear anything, it doesn't say anything. Doesn't hear, doesn't say. All right. So as I mentioned, transistors are what you need to get a microphone to be usable in any sort of electronics, whether you're writing to analog tape or you're writing to computer memory. You need to get to at least 1 volt. And then from 1 volt, you can easily get to 3 volts, 5 volts, whatever you need for that specific electronics. So how does that work? It works through a transistor. So the current coming out of this is very small. Now what a transistor does is it takes a small current and it makes it into, it takes a small current and it goes to a device where it will open a gate to allow a larger current in. That's how the amplification works with a transistor. Okay, so I'm going to draw the diagram of a transistor. It's a base, collector, and emitter, but forget what we call it. We're just going to make a big pipe of electrons going down. And this is a bunch of small electrons. You can see it? So the small electrons from the microphone go into this material, and the material will open the gate for these large number of electrons. So let's just say that, so basically I think the most it will do is maybe 50 times. We'll just use that. So when one electron hits this material, presses against this material, it will open the gate to 50 electrons. And 50 electrons will go down. If 2 electrons hit, then it will be 100 electrons, right? And 3, it will be 150. You get the idea. So every electron from the microphone that hits the base of the transistor will release a voltage, the electrons from another source of voltage that will go down through the wire. And then you'll take this, so let's just say you had 1 to 5, or 1 to 50, you take this 50 and put it into another transistor that would once again amplify it. So that's why you need multiple transistors. There's no one transistor that can multiply all the voltages. And I'm going to explain why it can't do that. And again, the reason is not theoretical. The reason is the property of the materials. The conductivity of silver cannot be changed. You cannot change the conductivity of silver, of copper, of anything. Every material that's in electronics has properties, and the properties say they can work within certain limits, right? So if you put too much current, as you know, through copper wire, it gets hot, right? It stops electricity flowing and starts generating heat, right? You probably experienced that if you've grabbed a hot wire. Well, why is that wire getting hot, right? But what you don't realize is that the heat, if you were using that wire as the signal from your microphone, that it would be losing the signal to heat. Well, that happens in very small ways throughout electronics. And plus, currents create magnetism. The magnetism can create currents in other wires. So there are a tremendous amount of problems that electrical engineers face. Temperature is another thing. So all these materials act different in temperature. So this microphone, right, if you're talking to the preamp, it's actually going to generate a different current if I'm using an 80-degree weather, let's just say, versus 60 degrees. It's American, Fahrenheit. So, they have to put circuitry in that that will deal with that. So again, because the materials dictate everything. You cannot make stuff up. Technology is how you put the materials together. You cannot just make stuff up in your head. The gain knob's obsolete because we have 32-bit flow. Ah, it just so angers me. Sorry. All right, so we're going to talk about a scale because a scale is sort of like a transistor. So we want to we have our big current, and where is this going to be? We want to make this on this. Do I want to make it on this side or this side? Yeah, so we'll just put on this side. So I'm going to put this on. This is our big current, right? So I'm putting two little weights on this side, and we want to move these weights up. So to move these weights up, let me see. I'm going to take one thing to represent the microphone. Okay, so if I put it on 10, right? You can see that it's moving 5. So now every little voltage here that I put here is going to move 5, which is the big current. And that's what you want. But we're going to actually change it a little bit so I can show you different... I wish they made these things really don't try and jump off the puzzle. All right, so I'm going to put it at 3. I think 6 will... So 6 will... So, okay, so it's at 3, right? This is our big current. So that means it's 6 and it's 7. If I put it at 7, right, it's going to go down a little bit. But let's just say I put it at 8. It's now saturated. It's gone down as far as it's going to go. You're not going to be able to move any more current, right, as you get in a smaller electrical current. It's the same way going the other way. If we go to 5, it's going to lift it up halfway. If we go to 4, it's not lifting it at all. This is too much. And this is true for all transistors, all electronics, all things in the physical world that we know about. It's there's a point at which a substance will start reacting to something, and a point where it gets saturated and it can no longer react to it. And that's the problem that each transistor faces when it gets its microphone signal. So like I said, yeah, if you know you're going to have the exact same small range of sound amplitudes, then you don't need to scale it like this. You just make the material so it's going to be perfect. But because we don't know, so we know that we have this this current here, right? But we don't know what the microphone current is going to be. So for right now, if we have it on 3 and I put it on 6, right, we're balanced, we're good. But let's just say, for the sake of argument, that we're going to have the person's going to be speaking louder, right? So if the person's going to be speaking louder, let's just say we put them on a 3, right? To get the optimal fidelity, where it's not going to be too little and it won't activate the transistor, or too much where it saturates and it no longer adds, a modulating flow or voltage to our mic signal, then we're going to need to change the amount of current going into our transistor. So we'll need to basically say, okay, well, we're going to move this down to 5. So that doesn't work. Am I thinking about this right? So move it down to 2. Yeah, so move it down to 2, right? We can't change. We don't know what the current that the microphone is going to generate because we don't know how loud the person's voice is going to be, how loud their singing is, whether they're using the mic far away, close. We don't know that. So if they're singing or they're speaking louder or softer than we expect, the only thing we can change is the current going into our transistors. That's why there's a gain knob. So you tell me, how can the gain knob ever become obsolete? Seriously, write in the comments, please. Tell me how bit depth has anything to do with it. Nothing to do with it. I'm going to do a separate video on that. But I want to do, just a ranting video. To sum it up, materials dictate everything. We can only work with the physical properties of the materials we use in electronics. We have to deal with temperature. We have to deal with heat and resistance. We have to deal with electromagnetic interference. We have to deal with different problems of different unmatching impedances and things like that. all these problems that we have to deal with. And again, we can't just force it to do what it already inherently is not capable to doing. All we can do is pick the materials, put them in certain ways, fabricate them in certain ways. That's all we can do, all right? There's no like person inside your microphone like saying this is what the voltage is. Voltages, transduction, everything that measures energy is just a change in the material, in the electricity or the sound or the magnetism through the material. And that's how it's done. So we don't know. The only thing we can really affect is the current that we're using to amplify. Right? We're using a big current. We're taking the small current, the microphone, we make that a little bigger. We take that a little bigger. We make that a little bigger. We can't, by the way, take that little microphone, split it in two. Like I get that a lot from my comments. Like, what are you thinking? One time only. You get the current, you amplify it, and you're done. Well, my wife is here, so I guess that's it.